Hey guys, another video for you. We're going to talk today about the REST interface on StackTach.v3. And now that we've got some cool pipeline processing going on with Oahu, we've recently extended Quincy and Quince to reflect some of the streams that we've got in there. So we've added a new resource, a /streams resource. And I want to show you now how we implemented that inside of Quincy, and then maybe later I'll show you how we expose that with the command line tool Klugman. I talked about Quincy and Quince and all the rest of it in previous videos in the overview, and the reason we called it that is, Quincy, the old 70s, 80s TV show. Quincy was, this relentless pathologist who, looked into suspicious deaths, and that's really what StackTach is about. Not only is it generating metrics and important timing data and performance data about your OpenStack deployment, but when things go wrong, notifications are a great way to find out what went wrong, because you don't have to look at log files across 50 different servers. You just get one set of events on a per request basis, and then you can find out what happened. So it's awesome that way. If you really want to see the benefit of that, you can start off with StackTach v2 and get a lot of that stuff already. But our new approach to working with the API is that this is just a small API really focused on just event processing, and it can plug into other architectures very easily. So one of the things that we're working on is to integrate this with HP's Monasca project, which is evolving towards a microservices type bus. In that situation, StackTach just becomes another service on the Monasca bus, and Quincy will be the tool for doing that. So what makes that neat is that we don't have to go back to the Monasca team and say, hey, listen, can you add a new resource to your API for streams? Because we can just expose Quincy on the bus, and it'll come back in the service catalog and say, oh look, if you want to do stream processing, here's the endpoint for doing it, and it'll point to the Quincy API. Anyway, we'll talk more about that in later screencasts. It's a very cool architecture, but for today we're just going to talk about these three components, well, two really. So like I mentioned before, we've separated the REST side of the house, the HTTP processing side of it, which is Quincy, from the implementation side of it, which is Quince, the nickname for Quincy. And we dynamically load the implementation at runtime through a configuration file. And the reason we did that is that we're not really tied to this implementation of how to do stream processing. So we think that if someone comes around with a better implementation or a better way of doing this processing, they shouldn't have to reinvent the wheel with it. We want the API to be the foremost thing. So we have Quincy, which is our REST interface, and we've got integration tests around Quincy to make sure that it's doing the right thing. And there's a dummy reference implementation that comes with Quincy that just is like a big fake and it just returns canned data that you can run your integration tests against. But then later, if you actually want to run this in production and do something cool with it, you can use the Quince implementation, which knows how to talk to Winchester and Oahu and actually talk to the stream processing back there. And our command line tool does the same thing. Our command line tool is a set of libraries that can work with Quincy and whichever backend you decide to use. So if you think you can do a better StackTach out there, absolutely go right ahead. And you know what? We've taken care of some of this heavy lifting for you. By all means, use Quincy, use Klugman, and just plug in your own implementation under the hood, and you're guaranteed API compatibility. So let's get into the gory details about how some of this works. Quincy is a REST interface. It's a versioned REST interface, so that as we expose new resources, we can just bump the version number. And we took a fair bit of time making sure we've got the architecture for that right. It's a little bit more complicated at first, but it makes things a lot easier down the road. So versioning is a very low-cost operation. We can bump versions relatively inexpensively and not have to throw the baby out with the bathwater every time we do for previous resource handlers. And so let's talk about how we do that. So we've got this is the screen configuration for the sandbox, and I've showed you this before. But basically, you know, we've got all these different window tabs that we set up here. This one here is where we set up Quincy. So we're using the G-Unicorn HTTP server, which is a Python WSGI stack, basically. And we're dumping the log file out to the screen, and this is how we get the WSGI API object. So there's a file, a module, a namespace called API, and there's a method on that, or a function called getAPI, and we pass into it our configuration information, which is this Quincy comp file. And that's how we're going to get our WSGI API, or our WSGI app, basically, to run. And so that's pretty standard issue stuff. And then in another window here, we're going to run Klugman with a streams command to try and get some data out of it. So this will talk to that. This other line down below here is just to show you that you can call it with no parameters, and that will give you the default implementation. So that won't load Quince. That's just going to load the stock one that gives you canned data back, which is useful for testing or just messing around. So you don't have to deploy the entire back end of StackTach if you just want to play with the API and see how things work, which is kind of nice. It's a very small implementation. So let's look at the Quincy config file. We've basically got two things in here that are really of interest. The first thing is that we're saying these are the enabled versions that we're exposing to our REST interface. We've got a version 1, we've got a version 2, and you know, realistically, right now we've only got a version 1. Version 2 is in there just to prove the mechanism for how we're going to support versioning, but very soon that's going to get solidified a bit, and we will have version 2, and then, you know, version 3, 4, 5, 6, 7, 8, 9 will follow relatively quickly, I think. And we're saying the implementation we want you to use for version 1 resources is from the Quince library. So we want to use the Quince library from a module called V1 Implementation, and the class for it is called Impl. And then for V2, we've got another thing inside Quince, which is our V2 implementation, which is the V2 Impl module, and again, the class is called Impl. When this thing loads up, it's going to load Quince, the library called Quince. And Quince is going to look in this config file to find out how it talks to Oahu. And in this case, we've got a symport import syntax, which says this Oahu config file, there's a class called config, and that's where you're going to get your definitions from. And we've talked about that before in previous screencasts. But this is how Quince gets initialized, basically. So if we go back to our screen thing, this is how we pass in that configuration file. The API is going to load Quincy, and we're going to get a web server ready to go. So let's look into some of the details on that. So now we're going to look at Quincy. Quincy, again, is the REST interface without an implementation. And this is a file called API. And API is the thing that's, remember we said in our screen RC that we're going to do API, get API. Well, this is where it comes from. So we go over to API, this is this file here, and there's a function here called getAPI, and we pass in the configuration location. And this just wrappers this inner one, just so that we can catch any exceptions. And the meat of it is up here, which is getAPI. And what we're going to do is we're going to have a dictionary of implementations, and there's going to be one implementation per version that's available. By default, we're going to load this dummy one, which is the default implementation for each version. And this is the one that's just the canned data. This is the stuff that is going to return a fixed set of streams, and the details on them are going to be fixed as well. And that comes from this namespace. So this is going to load V1 Impl with Impl. This is out of this module. This is in this directory, as opposed to the one that I showed you in the config file, which was Quince.v1. I know the naming is a little similar and makes it a little bit confusing, but these are different namespaces. So I load this one up. I say I'm going to enable both versions by default, but we can override that in the config file. So now we're going to load up the config file, and we're going to break out what the enabled versions are if that's defined. So, and in our configuration file, we're enabling both versions as well. So we have enabled versions 1 and 2 anyway. So let's go back to there. So now we've got basically a web server ready to go. We have an implementation for both versions of the API ready to go, but they don't do much. They're dummy implementations. Let's get into some interesting stuff here. So now, and this is where we load the implementations up and we start to populate our dictionary. But if we did have a configuration file come in, then now we want to load our implementations from that configuration file instead. So that's what it's going to do. It's going to, when we get up to the implementation up here, it's going to go through for each version. We have our schema, which is our Falcon definitions of the REST interfaces. So this is where we get this is our stock API. This is the important stuff that we define, and it's going to be rigid for Quincy. But then we have the implementation of this schema separate. So what it's going to do here is it's going to find out what the implementation is from which implementation to use from the config file, and it's going to load it and it's going to initialize it. Right? So we're going to say, here's the API, here's the implementation to use, and here's the version that you're actually implementing. And then we get our API object back. So that's pretty simple. So now we've got a dictionary that has all of the REST handlers, and all of the routes and everything are going to get added, and then we have the implementations for doing this. So let's look at one of those. So let's look at the version 1 implementation here. And in version 1 we've got, so this is the schema object that I talked about. And when we initialize it, we have a couple of routes that we add. So one is the streams route, and that gives you operations on the entire collection of streams. And then we have a stream item. So if I specify a stream ID, then now I'm doing an operation on one particular stream. So we add these two routes, and then we've got our two collections for it. So we've got our stream collection, and we pass into the implementation to use for it, and the stream item, and we pass into the implementation to use for it, which all came from our configuration information. And this is typical Falcon stuff up here. So our stream collection, there's a bunch of different operations that we want to do on it. There's a bunch of get operations for streams. Right now it's mostly just get operations. We will be adding delete operations. We will be adding put operations for resetting streams and everything, but this is just to get you going. And one of the things that we look for here, we start pulling out all the parameters. So we can filter our streams by things like older than a certain time, younger than a certain time, what state is it in, what's the name of the trigger that we're interested in, what are the distinguishing traits that we want to search for if we want to find a particular stream that's out there. And then we call the implementation, and the implementation has a thing called get streams on it. So this is the only thing. If someone wanted to make their own StackTach REST interface, all they have to do is they have to implement this get streams method. They don't have to do anything with REST. They don't have to do anything with Falcon or GUnicorn, or they don't have to make client tools. They can implement this thing, and they can make their own stream processor on the back end. And then we return a JSON structure from whatever we get back. And then on a particular item, and this is the one where we override some of the other HTTP operations. In this case, we get that particular stream. We can ask for details on it, yes or no, and then we just return that. And things like Klugman, which is the command line tool for this, knows how to interpret that JSON payload and render it in a pretty fashion. Delete operations, you can delete a stream, you can reset a stream. These aren't implemented just yet, but that's the hook for it. So this would be our version 1 API. That's the only thing we expose. Is we have a couple of we have a resource called streams, and that's it. When we get into this is the default implementation for it. So this is the Quincy V1 implementation, and again, Quincy is the REST interface, so Quincy has a dummy implementation. And when we look at our implementation here, we have a get streams call on it, and the only thing we do is we return a fixed set of dummy streams, right? End of day exists, collecting, error, request ID, just canned data. And our dummy stream up here pre-populates like last updated with the current time and returns an empty list of distinguishing traits. Nothing fancy. And then we would have to implement a get stream operation, which returns a single item. And then we have our delete stream and reset stream operations. So again, if you wanted to do this, you implement this class. Now you've got a whole REST interface for talking to your own StackTach compatible service. But let's look at the Quince implementation, because that's really where the rubber meets the road. The Quince implementation is the one that goes and talks to a Wahoo and knows how to talk to the database and can actually get some interesting stuff from it. So this file here is again called V1 Implementation. I know it's confusing, but it's from the Quince namespace. So this is the one that does something real here. And what we did here is we have our impl class, and if you notice, there's no stream definition in here like we had in our fake one, because we're going to use the stream objects that come back from a Wahoo. And we look in the one other thing that's interesting is as we fire off all those chains of implementations, we have a scratch pad that goes with it. So we can do a dependency injection mechanism, so that if I've implemented version 1 and then I implement version 2, I can share stuff between those two implementations. And in this case, we're using that to share our connection to the database. We don't want to have, for let's say we have 10 versions, we don't want to have 10 connections to the database for every implementation. We want them to all use the same implementation. So we use a scratch pad for that. So this is just a little place that you can store some stuff, and it's shared between all your implementations. So in this case, we're just looking to see, do we have an Wahoo configuration? If we don't, then get our driver from it, store the driver in here, and then for subsequent ones, we'll pull that information out of the scratch pad, because we know it's already there. So we know what the configuration is, and we know what driver we're going to use. It's all ready to go. And in this case, we're just going to proxy these calls right through. So when we do a get streams, we're going to go right through to the Wahoo driver, and there's a method on that called find streams, and we're going to pull out the streams and return them. And same thing with get stream. We call the driver, and we do get stream. So the implementation here is probably about as simple as it gets. So we're really just gluing these two libraries together. We're gluing together Quince with the Wahoo pipeline in this one little class, and that's about as difficult as the implementation has to be. So let's fire this thing up and have a look at it. See it work in operation. Okay, so we're going to start the sandbox, and this will reinitialize our virtual environment with all the latest code. And we've just generated all the events, and the pipeline's processing, it's doing all that sort of stuff. But now if you notice down here, we've got two other windows. We've got our Quincy window, which is our web server running, and we've got our bash shell, where we're going to do our Klugman type stuff. So now we just fire it up, and this is GUnicorn, and you see we passed in the Quincy configuration file. And when it fired up, it said, okay, this is where we're using, this is the configuration file that we're going to use, so it found it. If it was none, then it's going to go back to the default implementation, which will be all of our canned stream information. And so now we've loaded Quince, and Quince is using the Wahoo driver from this location, which is this little file, which all the other workers and daemons and Yagi handlers and everything, they all use that same little file. And for our version 1 implementation, we're using this object, which is our Quince V1 implementation, which is what we want. It overrid the default handler. And for version 2 requests, we're going to use the version 2 implementation. Version 2 just inherits from version 1, so anything that was defined in version 1, we have a chance to override it in version 2, but in our situation right now, we're just proxying all the calls right through down to the version 1 handler. So any requests for like streams and things will come through here. So now our HTTP server is ready to go. Let's go over to here. And so that did a streams call. Wonder what that... Okay, there we go. So I just, sorry, let me show you what happened here. I just did streams again. The reason that we didn't get anything the first time through was because the web server wasn't connected to the back end at that point. It wasn't fully initialized at that point. So anyway, I just did a Klugman streams call, which just returns all the streams. Normally, you wouldn't really do that in practicality, but you can see all the streams. We have a stream ID here. It's in the process state, which means it finished. It was last updated on this time. The trigger name for it is request ID. So that's our request ID stream, and the distinguishing traits for it was this request ID is this value. So that's our distinguishing traits. And if we look at this other one up here, which is an end-of-day exists stream, we see that the payload was this instance ID, and the audit bucket was for this date. So we see that this stream is still collecting, is still waiting for stuff to happen here, and some of these got processed. So that's pretty handy. Now, I mean, if we use some of our Klugman filters, we can reduce this down and say, let's just do trigger name. Well, we can just do a -H, and we can see all the different options that we have here: older than, younger than, trigger name. So let's do trigger name request ID. What did I do wrong here? Okay, so here was what the problem was. I had the name wrong. So if I do like a trigger name for end of day exists, and I do that search, now I'll just get all the streams that have end of day exists trigger types. If I want to get a particular one, if I don't want to go through the collection, I can just take a stream ID like that and say for a particular ID, paste that in, and get the details on that one. I've got some debugging information in here, but once we get the details option in there as well, you'll be able to actually see all the events that came in for this, or things like if an exception occurred, we could see why this thing failed. If it was in the if it was a trigger error or a commit error, we could see what the exception was in the stack trace and what happened, and then, like I say, all the details on the events inside that stream. So that's how these two pieces work. So hopefully that should give you an idea for how a call comes through into Quincy and gets handled by some implementation, and how we deal with different versions inside of Quincy and Quince, and how we expose a REST interface onto the pipeline. There's going to be a lot more going on into this. There'll be more resources added and a lot more commands added. So stand by for more screencasts that are going to dive into that in a little more detail. In a follow-up screencast, I will probably show you how we deal with multiple versions inside of Klugman, and how Klugman works to show these little boxes and all this pretty printing and stuff here. Okay, thanks. Stay tuned.